Okay, so now that we've seen how to set the mass, let's talk about this a bit more in depth, because there are actually more ways of doing this than just setting mass. I only use mass because in my opinion it's the easiest to understand and a good introduction into the concept of energy distribution. But there's actually an alternative that side effects would prefer you to use, and that is density. So for now, let's take out the mass here from our override attributes so that we're back to the defaults, and let's turn off our mass settings. And the thing with density is the difference to mass is absolute and density is relative to the volume. So in other words, by setting the mass, you set an absolute number for the whole object and it's not changing anymore whatever you do, which again I think makes it easier to understand. But density is more like the bigger an object is, the more mass it will have. Therefore, the logic is actually quite simple. It's density multiplied by volume equals mass. So you can see the mass actually will be calculated automatically. And there is already a default density for all the objects in our simulation that you can find in the RBD bullet solver. Here right under solver bullet object, down here under physical, there is the default density of 1000, and which is 1000 kilograms per cubic meter as far as I know. Does it tell you that? No, it doesn't actually explain it to you. So what this means is by default, the size of an object will be taken into account. So if I turn off the mass settings and just play this, it looks like this. And the interesting thing now is if I scale down my sphere, you can see that the mass will have changed, which of course is very natural and very close to how it is in the real world. In my opinion, it just makes it actually in practical terms a bit harder to work with. Now, if you say, wait a minute, this makes a lot of sense for me and I want to work like that, absolutely do that. I just want to show you that you have alternatives with a mass, or you use the density, which is volume based. And of course, instead of using the built-in density for everything, which we can set to 1, because as far as I remember this will be multiplied, you can of course also set with a point wrangle the density directly, just with an attribute name density. So by giving the sphere here a density of 1000, let's say, and let's call this density, and the wall a density of, let's say, 10, then of course you can still control the distribution of energy, only with a difference to before, that now the scale of the sphere will influence the final mass even more. And this way, now it's even stronger by making it bigger. Again, if you like that, feel free to use it. The problem I have with that is that in practical terms, sometimes the size will change slightly and you still want to have the same reaction to your environment. And this is why I personally prefer to set the mass here as an attribute override and then set it directly, because now I can say, okay, this should be the energy distribution, and even if I change my sphere size, it will still feel the same as before and I don't have to rearrange all my attributes. Now, a small word of warning. As I said before, RBD being a third-party solution isn't always as stable or predictable as I would like it to be. And one of the things is how it handles mass sometimes. I can't show you this problem on this super simple example because simply here it doesn't happen. So I have to quickly show you a version of this that we will talk about later on. But it's the same concept here. We just have multiple actual bricks that we will break apart. Again, don't worry, we will look at this example in a later video. And for the bricks, I set the mass to 0.1, and for our wrecking ball here, a mass of 5. And for this distribution, the whole behavior is quite predictable and it behaves as you would think. But now something weird happens. If I lower the mass of my bricks here by 1/10, it still kind of works fine. But if I go further down, so I basically make the bricks lighter or less resistant to energy influence, I would actually expect that they would fly even further, but that's not actually the case. If I lower this to 0.0001, which of course is very low, then this happens. So the complete opposite of what you would expect. So just keep that in mind. You can't go endlessly with this logic. At some point, for some reason I can't fully explain to you, the behavior turns around and then the whole thing does not behave as you would expect. So make sure you're careful with your numbers, and if you go too low, actually try the opposite, go back up and see where the sweet spot is, where the behavior starts to make sense again. But nonetheless, as long as you stay with your values in a reasonable area, then all the concepts we just talked about still apply. So feel free to use whatever works for you, either density, which is the default, and the logic is density multiplied by volume in 3D space equals mass, or you go the shortcut basically and override the mass directly as we've seen in the last video. Then just make sure that you add the mass here to the override attributes from SOP, otherwise it will ignore it. And then the advantage is you can set an absolute number that will not change when you change the size of an object, which I find personally easier to control, but it's up to you what workflow you prefer. So I hope this is helpful. Thanks very much and see you later. Cheers.